Jones algorithm. Now this is one such algorithm that deals with the face detection by addressing the aforementioned issues. It uses the integral image representation for the issue of feature computation, the AdaBoost training algorithm for feature selection, and a cascade of classifiers for real timeliness. Now integral image. The question here being, can a simple feature, that is a value, indicate the existence of a face? Now let's see some properties about faces in general. This is a general property that the eyes region is darker than the upper cheeks for a natural reason that eyes are into a depression into the face while the upper cheeks or the nose bridge region is an elevated area from the face and hence making it brighter than the other regions of the face. And this knowledge is referred to as the domain knowledge. From the domain knowledge we get two values. Firstly, the location size, that is where the eyes and nose bridge regions are located and what is its size, and the value which tells it how darker or brighter it is as compared to other parts of the face. Rectangular features. Now the Viola-Jones algorithm uses the two rectangular feature. There are three types of rectangular features, which are the 2, 3 and 4 rectangular features, but the one under consideration is the 2 rectangle feature. The values discussed above can be calculated by the summation of pixels in black minus the summation of pixels in white area, which is nothing but the darker area minus the brighter area. For example, the difference in brightness between the white and black rectangle over a specific area, and this gives us the value of that specific area. Now, another question to consider is that why not pixels instead of features? Features encode domain knowledge, whereas features-based systems operate faster. We need features for higher and faster computation since it results in more efficient techniques which are applied after face detection. Image to integral image computation. Now let's see how this computation takes place. This is a 3x3 input matrix, and this is the resultant integral image. Now each pixel is calculated by taking the entire sum of all the pixels above and to the left of the concerned pixel. Now let's take an example of this particular pixel 4. This is attained by taking this pixel into consideration. So 1 plus 1 plus 1 and the pixel itself gives us a value of 4. By making use of the integral image representation, we can compute the value of any rectangular sum in constant time. Now for example, the integral sum inside rectangle D can be computed as the summation of points A and D minus the summation of points C and B. On a similar note, the 2, 3 and 4 rectangular features can be computed with 6, 8 and 9 array references respectively. Owing to all this, what we have discussed so far, feature computation takes lesser time and hence it's preferred over pixel computation. Feature selection, which is our second issue while considering the Viola-Jones algorithm. The problem with feature selection is that there are way too many features. Consider a sub-window of 24 by 24 pixels. There are about 160,000 features which result from all possible combinations of orientation, location and scale of these feature types. So it's basically impractical to compute all of them, although it is possible, but it's computationally very expensive. So for that we have to select a subset of relevant features, those which are informative to model a face. The hypothesis considered in this case is that a very small subset of features can be combined to form an effective classifier. So this hypothesis says that instead of considering a large subset of features, we consider a small subset of features but with which form an effective classifier. And this particular hypothesis forms the backbone or the basis of the AdaBoost algorithm. Now, what does ADA in AdaBoost stand for? It stands for adaptive boost. Now, this particular algorithm constructs a strong classifier as a linear combination of weighted simple weak classifiers. So we can see here that F stands for the strong classifier, where X stands for an image, and this is the summation of the products of the weak classifier with their respective weights. Now, features as weak classifier. Now, each single rectangle feature may be regarded as simple weak classifier, and these, when multiplied with their respective weights and summed up, give us the strong classifier of the image. AdaBoost performs a series of trials, each time selecting a new weak classifier, and here the weight which is associated with each weak classifier determines its importance. So we can choose to neglect or accept any of the classifiers based on the weight associated with them.